In what way can these observations help in improving the precision of measurements and understanding light-matter interactions, particularly when dealing with scattering phenomena? What does it mean for the intensity of Rayleigh scattered light to be inversely proportional to the fourth power of the incident light wavelength lambda? How is this relationship derived, and why is the fourth power of the wavelength significant in determining the intensity of the scattered light? How does the wavelength of the incident light influence the scattering behavior, and why is it important to consider this dependency when analyzing Rayleigh scattering? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does this inverse proportionality affect the overall intensity of scattered light as the wavelength increases or decreases? What happens to the intensity of Rayleigh scattering when the incident light wavelength is doubled or halved, and how can this information be used to predict scattering patterns? How does this relationship compare to other types of light scattering, and what makes Rayleigh scattering unique in this regard? Why does the intensity decrease so rapidly with increasing wavelength, and what are the practical implications of this for experiments or applications that involve scattering light from different materials? How can this understanding of the intensity-wavelength relationship be applied to various scientific fields, such as atmospheric science, material analysis, or optics? What are some real-world examples where this principle is critical, such as studying light scattering in the atmosphere or analyzing the properties of nanoparticles? How can the inverse fourth power relationship be used to refine measurements or calculations involving Rayleigh scattering, and what factors should be considered when interpreting results in light of this dependency? What does the equation represent in terms of Rayleigh scattering? How does this equation relate the intensity of scattered light to the intensity of incident light? Why does the wavelength appear in the denominator to the fourth power, and what does this tell us about the relationship between the scattering intensity and the wavelength of light? How can this equation be interpreted in terms of how light interacts with a medium or a particle? What does it mean for the intensity of scattering to be inversely proportional to the fourth power of the wavelength, and how does this affect the scattering behavior at different wavelengths? How does this relationship explain why shorter wavelengths, such as blue light, scatter more than longer wavelengths, such as red light? What is the significance of the term in the equation, and why is this power chosen specifically for Rayleigh scattering? How can we apply this equation to predict the scattering behavior of light when given information about the wavelength of incident light?